Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, I am Hassan Shabir, Computer Science lecturer in University of South Asia. This is our lecture number 10, continuation of cloud computing. And before we start our lecture, let's have a recap that what we have covered so far and what's our today's agenda. In fact, our today's agenda is same as our last lecture's agenda, but we ended up our discussion with some case studies, and now we will discuss about some service quality matrices. But before starting service quality matrices, let us have a review of the last lecture. In the last lecture, we discussed about cost matrices and pricing models. We discussed about that how a cloud service provider is charging you, and if you want to migrate your infrastructure over the cloud, what are the considerations you as a user, you as an organization have to keep in mind. Either it is beneficial for you to migrate your infrastructure over the cloud if your particular application's legacy application needs to be deployed over cloud environment, or it is beneficial for you to build an on-premises platform, on-premises cloud infrastructure. So there is a comparison. We have discussed about the comparison, how you can compare all the services, and we have seen with the help of example, with the help of different case studies, where there is an upfront cost that is involved, there is some ongoing cost that is involved. We compared with the on-premises system environment with the cloud environment, and we have figured out that if we need our service to run for a long time, it is beneficial for us to migrate our infrastructure over the cloud, because there is no maintainability cost involved, there is no initial cost involved, but they are charging you for their services, for their particular services that you are using. And in fact, if you compare your in-premises or your on-premises record cost with your own cloud cost, there will be a huge difference between these two costs. And we ended up our discussion there, and in today's lecture what we will see, and in today's lecture we will continue discussion about cloud management consideration, and these consideration, let's see what are these considerations are. And in these consideration, design and development time, we keep in mind that these cost that of the particular service that we are using have to be reasonable during the design and development phase, during the deployment phase, service contracting phase, and provisioning and decommissioning of a service. Okay, these are different phases that are included in the cost management considerations. So on the basis of these phases, how a cloud service provider is actually charging us, there is a pricing models there are some predefined templates that they can use to make a pricing model. That is a market they have, in which they have to consider, they have to keep in mind that the market competition is very high. Okay, someone else come and offer lower rates, they have to make their model as much as better, as much as comparable with others. There is some overhead during the design, development, and operation of a service. There is some cost they have to take. You create a model where such overheads should be overcome. Like if you are making a cloud service and there is some upfront cost, there is some overhead cost. You outsource some of the service code, and your budget is got over budget. Your budget is got over. and you have to manage your over budget cost and have to pay. Either you are gonna charge a single consumer for that particular over budget, or you gonna charge to whole customer. How you gonna charge them? That is basically defined in the cost template. And cost reduction considerations, because you also have to keep in mind the infrastructure that you are providing is shared. You are not giving them whole infrastructure, you are giving them a particular piece of your infrastructure. Okay, if your infrastructure, cloud infrastructure, have thousands of gigabit of RAM, you are not giving particular user the whole RAM. Okay, you cannot charge a single particular user for that. Okay, your IT resources are being shared. Your cost model should be as compatible, as much as elastic for whole customers, whole users. So pricing model for the cloud service can be composed of cost matrices, and by keeping view all these considerations, there is a pricing model that you need to compose. And what are the considerations that you as a cloud service provider should keep in mind before charging your clients, before charging your customers? One, the cost matrices. Other, fixed and variable rates definition. You have to define some lower rates, some higher rates. There are some variation between the rates. You are not going to charge everyone who is using your service for a longer period of time and who is using your service for a shorter period of time. You have to define some variations of rates. You also offer some discounts or loyalty programs. Okay, someone is using your one VM, your cost model should be as elastic to offer rates to offer particular rates to a particular user that is using only one VM, as well as someone is using 10 VMs on your server. You have to offer them discounts. Okay, cost customization possibility. If I as a cloud consumer have to use 10 virtual machine and I am out of budget, if I use all the virtual machines of Windows, I get over budget. I have no budget for operating my virtual machines on Windows platform. But I can manage if I use 5 virtual machines that are hosted on Windows server and 5 virtual machines on Linux based server. I can manage. My budget can be managed here. So there is a cost customization possibilities in your pricing model as well. And if there are some major clients, some big clients, there will be some cost customizations, negotiation option for your customers available in your pricing model. In this, we are designing a model. We are thinking that we want to design a model for our customers, okay, as a cloud service provider. So these are the considerations that a cloud service provider should keep in his mind. One, cost matrices, how they're gonna charge for the particular services that a cloud consumer is using. Fixed and variable rates definition, they have to define some fixed and variable rates as well. Some discounts for their loyal customer, for their customer who are using their service much more as compared to other discount offerings. Okay, so cost customization possibilities. You have to give them customization options. They can customize the resources that will be in their budget, that will be according to their budget. Negotiation by customers. Some of the clients that are major clients that are gonna use your service for the period of different years, you have to define your model accordingly. You have some negotiation options for that particular customer, as well as some payment options. How they are paying annually, monthly, and all these. Okay, so let's take a case study. What we have discussed so far, let's take an example of a case study. Okay, there are different pricing offered by a cloud service provider, and actually different cloud service providers are pricing, their pricing model is according to that diagram that I'm showing you in future slides. Okay, upcoming slide. See, there are different instances like small VM, medium VM, large VM, VM with large virtual RAM, and VM with large virtual CPU. And they have different configuration and specification as well. And there are different operating systems that are running on different VMs, Linux, Windows. And Linux is, is an open source, so their rates will be lower according to their pricing model. And the Windows is licensed. You have to pay before you purchase a Windows. So you can see that the hourly rate of a Windows environment is higher as compared to the Linux one. So in small virtual machine, what you have is one CPU, 4 gigabit of RAM, virtual RAM, VRAM, and 20 gigabit of storage. And in this, if your particular application can run efficiently on that specific environment with the configuration of one virtual CPU, 4 gigabit of RAM, and 20 gigabit of storage, and you know that you have to use for a 2 or a 3 hour that service, you can use that option of pay-per-use hourly rate, and they will charge you 50 rupee if you use Linux virtual machine and 80 rupee if you decided to use a Windows virtual machine. Okay, and your model and your work and your application, you keep in mind that the application you're gonna use on that particular small virtual machine should be compatible with the 4 gigabit of RAM. It does not operate if your application size is over 20 gigabits. Okay, if your storage size is exceeded, then actually you will be charged according to the VM of medium VM, because it's an elastic computing. As I said, your number of your resources, the size of your storage, the size of your RAM increases. The elasticity means they will scale up your environment and then charge you accordingly. Okay, and if your particular application needs much higher processing, then you can use VM with a large CPU where 32 virtual CPUs, 16 GB of RAM, and 20 gigabits of storage, and you can see that they will charge you 900 for Linux environment operating system and 1000 for Windows operating system. And in the next slide, let's see, if you are a loyal customer and you want to use their service for a longer period of time, there is an upfront fee. You can pay an upfront fee of 500 initial cost, and then on the hourly basis they will charge you 30 rupee for a Linux platform. And in the VM with the large VRAM, you see in the VM with the large VRAM, what you have to pay 750 rupee upfront cost, and then you are not paying 800, almost 900 for the Linux OS. You are paying only 400 for 1 year, the period of 1 year, by paying 750 as an upfront cost. So this will be beneficial for the customers who gonna use your service, cloud service, for a longer period of time. So your pricing model should be variable. Okay, that is the example, and almost nearly this is the very close to the reality. Okay, all the cloud service providers are offering rates that are comparatively as much as near to my rates that I have shown you in that particular diagram. So how you can measure the quality of a service? These are the service quality matrices. These are the matrices by which you can measure the quality of a service. Okay, these are the matrices, or these matrices that define your quality of service are actually depicting your SLAs, service level agreement. In a cloud service provider SLA has said that their server will be 24/7 on. Okay, so the QoS, quality of service, can relate to the SLA. Okay, you can relate your SLA, the SLA of that particular cloud service provider is giving you, with the service quality. is it true that the particular service is on for the 24 hours during the whole year, as they are mentioning in their SLA? That is service quality matrices. How you can measure the quality of a service. This include availability, reliability, and what is in availability? This is then uptime, downtime, and service duration. Okay, uptime means how much your service, the particular cloud service provider's service is up, and downtime means how much time it has taken during a particular failure. That is your downtime. And what is service duration, and how this is your total service duration, for how much particular time the service is running. That is your service duration. And what is reliability? Reliability is like minimum time between failure and guaranteed rate of response. That is reliability. It means that if I request something over the cloud, they will respond me back with results. That is a reliability. How much time, the reliability rate, like they say that they are 99.5% reliable. It means that my request that I will send to the server I am pretty much sure by their measures 99.5. It means that I will get my response back with a probability of 99.5%. That is reliability. So the performance is also a service quality matrix. We can check the quality of service by the performance, and performance is the capacity and response time. Okay, they are delivering me response. I am getting response from a particular server. If I am requesting something, I am getting back my response as results. But how much time it is taking, that is performance. Okay, performance matters a lot, as well as scalability. Scalability is the traffic on my website increases suddenly. How the cloud service provider are managing this kind of issue. That is capacity, fluctuation, and responsiveness. This is scalability. If the number of traffic increases, number of user increases, the scalability, that is scalability. They increase, they give me more bandwidth, they provide me more storage, because the user are uploading on my website. They will assign me storage space accordingly. That is scalability. And resiliency. This means due to some failure, meantime, how much time it is taking to switch over. Okay, there is some replication of our data, of our VM, of our whole server. In fact, it's been replicated over the other VM for the backup purposes. If due to some reasons my virtual machine, my web application fails, how much time actually the cloud service provider is taking for the recovery purpose. Okay, that is resiliency. And service quality matrices are required to be quantifiable. These are the quantifiable, repeatable, comparable, and easy obtainable. These are the characteristics of a service quality matrices. So quantifiable, that you can assign some quantities over it. Repeatable, if you measure them, you get the same results. And if you quantify something, and if you repeatedly doing this, and the results that you get in the form of some quantities, they must be comparable. You can compare the quantity of one thing with the other service quantity. That is comparable and easily obtainable. That the other if services can easily obtain the results from their service. So what is service availability matrix? We have discussed availability, performance, scalability, and now we are discussing about service availability. The availability rate matrix is the value uptime value जो होती है, इसे हम कहते हैं. Actually, the uptime value we call it the service availability matrix. In service availability matrix, the availability rate is uptime value. How much your service is up. And it is measured as a total time, uptime, divided by total number of time. Let's suppose my service is up for 20 hours and the total duration of a day is 24. So I divide 20 by 24 and I will get total uptime, that is applied over information as a service, platform as a service, and software as a service. And the minimum uptime of a cloud service provider offering is 99.5%. This means that almost near to 100% they are available. That is availability matrix. And the equation is total uptime divided by the total time. Here with this matrix you can get the total uptime of your particular service. Now, downtime duration. This is reverse uptime, reverse of the uptime. Expresses the maximum and average continuous downtime when the service outage duration. When a service fails, and from which time the service fails to the time the service starts running, that is your downtime. And it is measured whenever the service outage event occurs. And it is applied over infrastructure as a service, platform as a service, and software as a service. Okay, so let's suppose you can say that 1 hour maximum downtime of my service during that month, and if I particularly say that minimum 15 minute average over let's suppose of a particular service. So there is another matrix, service reliability matrix. Reliability, we have discussed this earlier. In the context of cloud, IT resources refer to probability that the IT resource can be performing its intended function under the predefined conditions. What does it mean? This means that if you define some measures, if you define some rules, and your service is performing well under these rules, he's not providing you some other disastrous results. Okay? He is not getting slow under some particular conditions. This is reliability. Okay, without experiencing failure. If you define that your service, your website will not down for the 100 user, and if 100 user are operating your particular website that are hosted over cloud, it will not face any failure. That is reliability. Okay, and focus on the duration in which your service perform as expected. This requires the service to be operational and available during that time. That is service reliability. So what is mean time between failure? Mean time is like there is a failure, 2 consecutive failures. Once a service is running, then it get fail, then up, and then service start running, and then it got fail. That is your mean time of a particular failure between 2 failures. And how you gonna measure this? Number of operations, okay, number of operation, normal operation divided by number of failure. Let's suppose my application is running for 15 hours, and my application got 2 times crashed. So I will divide 15 by 2 number of failures, and I will get mean time of my failure matrix. And it is applicable to information infrastructure as a service and platform as a service. So service reliability rate matrix, it is the percentage of successful outcome, service outcome. So measure the non-critical error during uptime, measured as a total number of successful operations divided by total number of requests. Measure as weekly, monthly, or yearly, and applicable on software as a service. Okay, so in case of this is basically request and response based, and we have discussed that the mean time failure is for infrastructure as a service and platform as a service, but not for the software as a service. But what is for software as a service? To check reliability of a software as a service, we have how we can check the reliability of a software as a service. It is like the number of requests responses divided by the total number of requests. That is simple. If my application is able, if my application has capacity to serve 100 requests. And what is reliability? Means 100% reliability means that if my application get 100 requests, he will respond me back 100 times. I will get 100 responses for my 100 requests. But reliability matrix says the number of successful responses, let's suppose it's my maximum capacity is 100 requests, but due to some errors, as you can say that due to some other technical faults, my application that are hosted on software as a service platform got 99 successful responses, has given you 98 responses of 100 requests. That is my reliability matrix for that to measure the reliability of my service. This is applicable to software as a service, and the minimum reliability matrix is 99.5 matrix, and that is quite good matrix for to adopt software as a service. So that is performance. What is performance? Service performance matrices. So performance matrices means that a service is performing under some conditions, that are some parameters. Service is performing efficiently under the particular circumstances, expected parameters. Okay, and measure with the respect to the capacity matrices. This is the performance matrices. And if I say service performance matrices refer to the ability of an IT resource to carry out its function within expected parameters. So capacity, network capacity, what is mean? Network capacity, bandwidth divided by throughput. Okay, this is your network capacity, and what it is applicable over information as a service, platform as a service, as well as software as a service, and measured as continuously expected. Like let's suppose 100 megabit per second. This is how we check performance of our network. If I say I have Zong, I am using Zong network and I have 2 MB per second network speed, how we can check the capacity of my network? This is the matrices. We divide bandwidth by throughput. Throughput is the maximum capacity. Bandwidth is actually maximum capacity, and throughput is how much he is actually performing. VM capacity matrices. These are the capacity where you can measure the capacity performance of a virtual machine. Measured as a feature such as number of CPUs, CPU frequency in gigahertz, RAM, and actually we can check. We can measure the performance and capacity of a virtual machine. I say if I want to measure or check the capacity of my system, but I will keep in mind that I will check the RAM, a processor, and the storage. And in case of virtual machine capacity, these are the parameters that we have to keep in mind. So we check RAM, gigahertz frequency of CPU, and storage size of in GBs, and that is that is also applicable on information as a service, infrastructure as a service, as well as platform as a service, but not software as a service. Okay. And if you want to measure the capacity of a software as a service application, how you can measure the capacity of a software as a service application, that is applicable the number of requests processed in a minute. How many requests this software as a service application that is running on a software as a service platform is actually processing. That is the capacity of a SaaS application. So these are the related service scalability matrices. These are the related to the scalability matrices. So how your virtual machine or how your specific VMs or a system is scaling up and scaling down. Let's suppose, for example, a virtual machine can be scaled up to 64 cores and 256 gigabit of RAM, and can be scaled out 8 replicated instances. That is your scalability. This means that if I have a CPU that has 64 cores and 256 gigabit of RAM, I can distribute that particular cores and space over 8 instances. That is scalability. And in term of storage, if I say I have some particular storage, let's suppose I have 1000 gigabit of storage, this is basically storage scalability. And this means that how you can change the storage capacity. Let's suppose 100 gigabit maximum auto scaling, like maximum is 100 gigabit, that is the capacity of my server, and a particular VM can get 1000 maximum gigabit from my system, from my particular server. Okay, that is storage scalability. But minimum is like 20 GB. If I define minimum is 20, but its maximum up to is 1000 GB. That is my storage scalability. And storage scalability, horizontal matrices, what are these? These are basically horizontal scalability. And in this, what's being done, maximum number of VMs. Okay, if I have like in previous example what I have said, that I have 256 gigabit of RAM, and if I want to distribute this much space over 1 VM or 10 VM, it can be scaled up over it can be scaled to 1 VM or scaled up to 10 VMs. That is server scalability. And server scalability vertical matrices that I have explained earlier. vCPU, virtual RAM in GBs applicable to IaaS, and platform as a service, for example, 256 cores maximum and 26 GB of RAM. And what is service resiliency matrices? These are the matrices that are used to measure the recovery time. Basically, if your system got disturbed, non-operational due to some errors, how much time it will take to get recover from that particular damage. When considered with respect to SLA, the resiliency guarantees are based on redundant implementation, source replication, and disaster recovery systems. Okay, this is resiliency matrices, and can be applied over 3 phases. Design phases, this is that to evaluate, there are some service resiliency matrices that you should keep in mind while you are designing something, while you are designing your application. And let's suppose the developer knows that this kind of errors can happen, and he is making sure if this kind of damage happen, and there are some backups for this. That is your design phase recovery plans. And there are some operational phases, like you deploy your application, and due to some measures, there are some measures in the difference in service levels in terms of availability, reliability, performance, and scalability metrics before, during, after down time event occur. That is operational phase. And there is a recovery phase. This means that when how much time an IT resource is taking from downtime to coming up to becoming running. For example, the mean time for a system to record a downtime event to switch over a new VM. That is your recovery phase. Let's suppose your VM got failed and you have your backup VM, and how much time they are taking from switching over your all the data that are present on failed VM to your new VM. That is your recovery phase. So there are two common matrices for measuring resiliency. Mean time to switch over, that is your actually when your VM got crashed and when your VM got start running. Okay? That is your mean time to switch over the replicated instance after the failure of VM. That is your actually mean time to switch over. And mean time is calculated as per month. Let's suppose in 1 month I got one switch over, one time failure, so it's mean we have to calculate it over months or on the basis of years. So it is applicable on information as a infrastructure as a service and platform as a service. And mean time system recovery matrices, these are the matrices for the resilient system to perform a complete recovery of from a VM failure. And these are actually expectations, and these are the expected times that if you think that that particular VM card might got crashed, and you are predicting the future on the basis of MTSR, mean time system recovery. And if you're on the basis of the previous history of your VM failure, you are predicting your future failures. That is mean time system recovery, and it is also measured in monthly and yearly basis and applicable to these three domains: information or infrastructure as a service, platform as a service, and software as a service. So let's find up our lecture. In this lecture we discussed about cost matrices and pricing models. What are different consideration that particular cloud service provider as well as consumer has to keep in mind before a consumer tries to migrate his infrastructure over the cloud, as well as a cloud service provider, how he is charging their customers for using of their to use their particular service as well. And there are different service quality matrices, how you can measure the quality of a service of a particular cloud service provider. There are different measures on the basis of scalability and on performance, reliability. We have seen all these, and inshallah we will meet in next lecture. And if you still have any confusion, you can email me, or you can watch this lecture again, or we will discuss it in interactive session. Allah Hafiz.